Hello everyone, I'm Monika Bhushan and today we are starting lecture number 2 of numerical integration. So in today's class we are going to see Simpson's 1/3 rule and Simpson's 3/8 rule under numerical integration. Okay, and in last class we have discussed, right, we have understood the concept behind numerical integration, and there only we said that we are going to see few methods under numerical integration. So very important method is Simpson's method, and we have to study two rules under Simpson's method. Okay, fine. So I assume that you have gone through first lecture, so you know that what is numerical integration and what the basic rule we have to follow under any of these methods. That if I have any graph, any curve which is not very well known to me, I am not able to find the area of this curve using calculus method, using theoretical method, then I have to take help of numerical integration. Fine. So in this, suppose this is the example of any curve, this is your fx, fine, and I have to find the area under this curve. So suppose mentioning one point here, x equals a, and suppose here x equals b, and I have to find the integration between a and b. And how do we write in calculus? We write that I have to find the integration of this function fx, correct, at between a and b. That means I have to find the area under this curve, or I have to find the answer of this definite integral. Fine. So these are all things we have discussed. So I'm not going to again elaborate on it. So what we said that I'm going to divide this interval, this big interval, into small sub intervals. Okay. And if right now we are focusing on only Simpson's method, so what will happen that, so in Simpson's method we discussed that we are going to find the area of these all small intervals using trapezoids where they are not exactly trapezoid. One arm of or one side of trapezoid will be exactly the same curve which the function has. Okay, so how it is possible? For that we will take help of quadratic polynomial. Okay, so one example of this quadratic polynomial is parabola. Okay, so what we are trying to do, we are trying to match a parabola with this function, with this curve. Okay, and for that in Simpson's 1/3 rule we will be focusing on two intervals. In between we will be taking consideration of half of these 2 points. Okay, suppose this is your a and this is your a dash, so we will consider one point. The point will be a plus a dash by 2. Okay, so these 3 points will be actually the points of parabola. Similarly, we will be keep on approximating this real curve with the parabola, where we will be considering two subintervals. Okay, and the 3 points will be exactly the leftmost point, rightmost point, and in between these 2 points, that is the midpoint of these 2 points. Okay, so this method is called as Simpson's 1/3 method, and in our Simpson's 3/8 rule what we are going to do, the logic is exactly same, but instead of considering just two subintervals, in Simpson's 3/8 rule we consider three subintervals. Okay, and when we will be seeing the question, it will be more understood that how we are doing it. Fine. And Simpson's rules actually give us accurate result if this function is having degree 2 or less than 2. Okay, so this is far better than trapezoidal method. And why so? Because in trapezoidal method we try to linearly approximate this function. So linear approximation is not as accurate as quadratic approximation, but we have limitation also with Simpson's rule. And what is the limitation? If the graph is very oscillatory, that means if the graph is this way, so it will be not that accurate if we are going to approximate this function even with the quadratic approximation, right? So we'll say that for highly oscillatory graph, Simpson's rules are not that accurate. Fine. So we are going to discuss these rules also, but before that we are going to see the question, which type of questions they ask. So here is the very first question. They are asking that use Simpson's 1/3 rule, okay, with 7 ordinates to evaluate this function. This function is what? This is the definite integral with the lower limit is 2, upper limit is 8, and the function is what? 1 by log x base 10. Fine, no? And they are asking us to use Simpson's 1/3 rule, and something they have given us. Fine, they have given us that use the rule with 7 ordinates. So we will first understand that what is the ordinate and why they have given us some value. Okay, so very first step is what? In Simpson's rule, we are going to see that what is the limit of this definite integral. So lower limit is 2 and the upper limit is 8. So that means I have to consider the points between 2 and 8, where 2 and 8 both are inclusive. Fine, we are going to draw one table. Okay, so the table will be what? Here is the x0, here is your x1, here is your x2. Fine, and something here it is your xn. We will come to know what is xn. X0 is this 2. Fine. So the interval starts from 2 and it is till 8. So your xn is 8. Okay. And then what you are going to do, you will come to know that how many intervals will be there. First thing is for sure that the very first interval is x0 is 2 and the last one is xn is 8. Okay. And accordingly you will be finding out the value of y. Fine. So at x0 is 2, what will be your y? Your y will be 1 by log 2 base 10. Okay. So whatever value it is coming, you are going to write down here. This is your y. Fine. No, the general form if I write down, this is a to b. This is your y and this is your dx. And y is nothing but y is only the function of x. Fine. So here your y is 1 by log x. Similarly, we have to find the value of y at each and every values of x0, x. This will be 1 by log 8 base 10. Whatever value is coming using calculator, we will be writing down here. Fine. Okay. Now we have to know that how many intervals are needed. How many parts will be there. So to know that how many parts will be there, we will be using one formula. The formula will be b minus a divided by n. Okay. And just we are going to give any name which is your h. Okay. What does it mean? B is 8. Okay, so this is my 8 minus A is 2. 2 divided by n. What is my n? So n in the question only they have given. They have said that use Simpson's 1/3 rule with 7 ordinates. Okay, what is ordinate? So this ordinate says us that how many values of x will be present here. Okay, so that means x0, x1, x2, it will go till what value? And it will go till 7 ordinates. So this is your very first ordinate, this is your second ordinate. So to have 7 ordinate, you must be having 6 parts. Fine, that means what I'm saying. So if n parts are there, okay, in between the interval, that shows that n plus 1 ordinates will be there. And how I'm saying? So suppose I'm just giving you one example of a smaller interval. Suppose the interval is between 2 to 4. Okay. I want to divide this interval between 2 to 4 into 2 parts. So initially there is no division. I want to divide into 2 parts. Fine. So this is your part 1. This is your second part. For that I will write down here 3 to make it equally distant. So how many ordinates are there? This is 1, this is 2 and this is 3. But the partition is only 2. Fine, no? So if n partitions are there, so n plus 1 ordinates will be there. So 7 ordinates means 6 partitions are needed. Okay. So here it is 8 minus 2 divided by 6. That means 6 by 6 is 1. Fine. So this 1 is what? This one will be treated as h. And what is h? H is the width of each and every part. So h is width of all equal parts. Fine. So I can write down that if it is my 2, so second will be what? 2 plus h. Okay. So 2 plus h is nothing but 2 plus 1 and it is nothing but 3. Similarly, what will be the value of x2? It will be the value of x1 plus the width. Okay. So this is your 4 and so on. So that means just you have to add 1 in each and then you will fill all those intervals. Okay, fine. I hope the points are clear to you. That means what we are doing here, they have said in the question only you have to divide in 7 ordinates. So 7 ordinates means what? You have to divide into 6 equal parts. Partition will be 6. So the ordinate will be 6 plus 1, that is 7. fine. And the length of each part or width of each part will be b minus a divided by whatever the partition I have to make. Okay, so this is your 6, that is 6 is nothing but n. So I got the value of h as 1, fine. So the next step is make the table of the values of x and y. This is your x naught, which is your a, and a is 2, and xn is nothing but my b is 8. Fine, they have only given between 2 to 8 I have to find. And I got to know that what is h, and I got to know that 6 equal partitions I have to make. This is the first partition, this is the second partition, third partition, fourth partition, fifth partition, and sixth partition. So if 6 partition will be there, so it will be 7 ordinates will be there, correct? No, this is your first ordinate, second, third, fourth, fifth, sixth, and 7 ordinates will be there. Okay, so next is what? You are going to write down x0, x1, x2, x3 and all, and then accordingly you are going to find the value of y. That means at x equals 3, you have found that what is your y? 1 by log 3 base 10 is this much. Using calculator I got. And then this is your y1, y2 and all. Fine. So if I got to know what is my x and y, next step is to use the formula of Simpson's 1/3 rule. Okay. So Simpson's 1/3 rule formula is here, and Simpson's 3/8 formula is here. Okay, so how to memorize this formula? The formula has come using whatever concept we have done just now. We have done the division subpart, and then finally we got to know that the area of all subintervals we have integrated, and we got this is the formula of Simpson's 1/3 rule. So now we have to memorize the formula. So Simpson's 1/3 rule, fine. Simpson's 1/3 rule, how to memorize it? 2 is missing here, correct? No, 1, 2, 3. So what we'll do, we will take help of this 2. This 2 we will fit somewhere. That means this is your 1/3 rule, fine. So this is 1/3 rule. I've written down 1/3, and h will be present here. H is what? Width of each and every partition. Okay, and then we will be having actually 3 parts. Okay, addition of 3 parts. We have to know that what each part will contain. Okay, we are going to take help of 2. So this coefficient will be 2 raised to 0. Suppose this is your 2 raised to 1, this is your 2 raised to 2. 2 raised to 0 is what? This is nothing but 1. 2 raised to 1 is 2, right? 2 raised to 2 is 4. Okay, so now, so very first box I'm going to fill with y0 plus yn. That means 2 extreme values of y. Fine, no? So this is your y0, this is your yn. Okay, so very second box I'm going to fill what? This is my 2. So I'm going to use all those even ordinates. So what is even ordinate? Y2, because y0 I have just taken. So y2, y4, y6, or till whatever the last ordinate, last even ordinate will be there. Okay, and this is my 4. Okay, so this 2 raised to 2 I just erased. So this is nothing but 4, and filling it with all those remaining ordinates. So remaining ordinate will be definitely, it will be my odd ordinates only, y1, y3, till whatever values I'm going to get, which is the last odd value, my yn minus 1, and this will be your yn minus 2. Okay, this is totally illogical whatever we have said. This is just to memorize the formula. Again, if I write now, what I am going to do, I'll start with 1/3 rule. So this is 1 by 3, h will be present always, and then I have to fill 3 boxes. Okay, so 3 boxes I'll just fill, but I know that this is Simpson's 1/3 rule. 2 is missing. I take help of this 2. So I'll write down here 2 power 0. 2 power 0 is 1. So nothing is needed to write. 2 power 0 is 1 only. 2 to the power 1 is 2. 2 to the power 2 is 4. Okay, so very first box I'll fill with the 2 extreme ordinates. So y0 plus yn, I'm going to add them. See, I'm going to write the summation of y0 plus yn. So this is 2. So I'm going to write down here what? Y2, and then plus y4 plus all those even ordinates. And here I'm going to write the remaining ordinate. So remaining, no doubt, is my odd ordinate only. Okay, fine. So this is my Simpson's 1/3 rule. What about my Simpson's 3/8 rule? So 3/8 rule, if I have to write formula for that, so 3/8, I'm going to write 3/8, and h is there always. So now again I have to fill 3 boxes, fine. So 3 boxes I'll make, And here what I'm going to do? So here I'm going to see the use of 3. Okay. So that means I'm going to write down here 1, 2, 3. I'm going to write down here 1, 2, 3. Okay. So very first box is same as Simpson's 1/3 rule only. I'm going to write here y0 plus yn. Okay. Now in this sequence 1, 2, 3 with 2, what I'm going to write down? I'm going to write down all those ordinates which are multiple of 3. So sum of multiple of 3 ordinates I am going to write down here. Okay. Okay, fine. And what I'm going to fill in the third box? So third box will be the remaining all terms. Okay, so remaining term will be what? Y0 is already used. So Y1 is not used. Y2 is not used. Y3 is used. So Y3 I'm not going to write down here. Similarly, I'm going to write down Y4, Y5, so on. Y6 will not be present here. Okay. So to write down the formula of Simpson's 3/8 rule, I'll just use the sequence 1, 2, 3. Okay, I'll write down here 1, 2 and 3. Okay, fine. So here I'm going to give importance on 3. So in the second box, I'm going to use all those ordinates which are multiple of 3, and the third box will be having all remaining ordinates. Okay. So we have the rule for n also. What will be the value of n in my Simpson's 1/3 rule? What will be the value of n in my Simpson's 3/8 rule? Okay. So here n will be multiple of 2. We have given importance on 2 also, right, in 1/3 rule. Okay. In Simpson's 3/8 rule, n should be multiple of 3. Okay, we said that we are going to use this 3. So n should be multiple of 3. Fine. But when n will be 6, then we can use Simpson's 1/3 rule also, Simpson's 3/8 rule also. Okay. So now till here we are done. Now I have to use Simpson's 1/3 rule where n is given to me. Fine. Ordinate was 7. That means n is 6. So I am using Simpson's 1/3 rule. How I am using it? So Simpson's 1/3 rule I have written down h by 3. So very last ordinate is y6. So I am writing here the very first y0 and very last ordinate is y6. And then this is what? This was my 2 raised to 0. This is my 2 raised to 1. In 2 raised to 1, I am going to write down all those even ordinates. That means y2 plus y4. Because after that, I cannot add. Y6 is already added here. And after that, I cannot add. This is the last ordinate. Fine. In between, how many odd terms are there? I have just used all of them. Fine. So that only we have done. We have got since all values. So we are just putting the value of y0. We are putting the value of y6 and so on. And finally, using calculator, we got the final answer of this definite integral is 9.7203. But actually this function, the function which is your 1 by log x base 10, this is not integrable by analytical method. That means using your calculus formula, you cannot find the answer of this definite integral. Okay, fine. So this is the importance of Simpson's rule. Okay, now we are going to see the second question. So in the second question, it is given that evaluate between 0 to 1 dx by 1 plus x taking 7 ordinates. Again, they have said that ordinates are 7. And what we said that if n partition is there, that means n plus 1 ordinate is there. Okay, that means 7 ordinate. This shows that n is 6. Fine. Again, here they have said n is 6. Okay. By applying Simpson's 3/8 rule. Okay. Hence, deduce the value of log 2 base e. Okay. So first we are going to see that how we are going to use Simpson's 3/8 rule. Okay. And then we will be coming to the next part. So what they have given us? This is your 0 to 1, 1 by 1 plus x and then dx. So your a is 0, b is 1 and then your function which is fx or you will say y is 1 by 1 plus x. Can you guess that between 0 to 1, if you are going to 6 partitions, so how accurate the answer will come? Okay, that means the graph, whatever is given to you, so you are going to divide in very small partition. So accuracy will be much higher. Okay, I'm going to draw the table. The table will be having the values of x and y. Fine, no? So what is your x0? X0 is your a and a is your 0. and this is your xn. Xn is your b and b is 1. Okay, in between how many partitions are needed? Partitions are 6, right? This is your first partition, this is your second partition, this is your third partition, this is your fourth partition, this is fifth partition, and this is your sixth partition. Fine. So in six partitions, how many ordinates are there? This is the very first ordinate, second, third, fourth, fifth, sixth, seventh. Okay, so that means 7 ordinates are there. Now I'm going to write what is the value of y. So y0 is what? Y0 is 1 by 1 plus x. This is my y, correct? No, 1 by 1 plus x. So 1 by 1 plus x. X is here 0. So this is 1 by 1. This is 1 only. Okay. So x1 will be what? x1 is x0 plus h. Similarly, my x2 is x1 plus h. And what is my h? H is the width of each and every equal partition. H I have to find using the formula b minus a divided by n. B is 1, fine, no? B is 1 and a is 0, n is 6, that means 1 by 6. So here what I am going to write? x0 plus h. So 0 plus 1 by 6 is 1 by 6. Here your x2 is what? x1 plus h, that means 1 by 6 plus h. H is again 1 by 6, that means this is your 2 by 6, 3 by 6, 4 by 6, this is 5 by 6, and this is your 6 by 6, which is your 1. Fine. So everything is coming correct. Okay, now you are going to write down all those values. This will be what? 1 by 1 plus your x1. x1 is 1 by 6. So you will get the value here. Similarly, you have to fill everything in this table. Fine. So same thing we have done here. Fine. No, same thing we have done here also. Okay. Now the next step is what? You have to write down the formula of Simpson's 3/8 rule. Okay, so Simpson's 3/8 rule, we know how to write down. What we are going to do here? To write Simpson's 3/8 formula. So here this is my h. What is my h? H is your 1 by 6. What is my h? H is your 1 by 6. Fine, no? And then I have to fill 3 boxes. Fine, no? 3 boxes I have to fill, and this is my 3/8 rule. So I'm going to use the sequence 1, 2, 3. So this is the 1. You don't have to write actually 1. This is 2 and this is 3. In 1, I'm going to write y1 plus y, whatever the last y is there. This is y6. Y6. The value I'll be writing down, that means 1 plus 1 by 2 I will be writing down here. This is your 1 plus 1 by 2. Fine. Into what I'm going to write down? All those ordinates which is your multiple of 3. That means y3 plus y6. But y6 is your last ordinate. So you cannot write here. You have already used it. So this is only y3. What will be in your third box? All those remaining terms between y0 and y6. Whichever you have used, don't use here. So this is your y1 plus y2 plus y4 plus y5. Fine. So now this is only the formula. So this formula, right? The same thing is written here, and then just write down the values of each and every term, and then you will get the answer. So this is what you have done with one part of this question. They have said that use Simpson's 3/8 rule and find the value here. Evaluate this definite integral. So you have done it. Now they are saying that hence deduce the value of log 2 base e. Okay. So for that, what I am going to do? So for that, I am going to actually do the integration using the calculus method. Fine. So for that, we know this is what? This is the formula. Formula is log 1 plus x is nothing but what? This is nothing but 1 by 1 plus x. Integration of 1 by x dx is what? This is your log x. So here you are going to get log 1 plus x, and this is limit between 0 to 1. And how do we write here? Log 1 plus, first we will be putting the higher value, and then with subtraction we are going to put the lower value. Correct? No, we are going to replace x with higher value. Now we are going to replace x with the lower limit. Fine. No? Log 2 minus log 1. You know that log 1 is how much? Log 1 is 0. So this is your log 2. Okay. So base is what? Base is e. And you must be knowing the value or use your calculator. It is nothing but 0.6931. Okay. 0.6931471. Very accurate value. And see the correctness of Simpson's 3/8 rule. Value we have obtained, this is your 0.6932. Fine, this is your 0.6932, and the exact value of log 2 base e is this much. Okay, so Simpson's 3/8 rule is really very accurate rule. We were actually dividing the interval between 0 to 1 into 6 parts. Fine. That means if we are partitioning with very large number, so you are going to get very accurate answer. Okay, fine. So if you find this class useful, please like and subscribe my channel. Thank you.